Welcome you to this evening's presentation. This presentation is being organized by the Mechanical, Agric, and Marine Division of the Institute. I am Mahadi Anderson, and I am grateful to the chair of the division, Engineer Dr. Okutu, for the opportunity to introduce to you our topic for discussion this evening, and the resource person who will be guiding us through the topic. The topic is tribology, a key asset reliability driver. On the look of the topic, it looks very simple, but it's a very compact one. Tribology is a whole field on its own. Asset reliability is a key thing in the asset landscape in today's asset management and reliability. So putting all of them together on one topic makes the subject very complex one. But we intend that at the end of the presentation, we should get the benefit of what we intend getting from tribology in terms of wear and lubrication, energy efficiency, durability and reliability, some cost savings, and environmental impact. Tribology is a multidisciplinary field, and it cuts across mechanical engineering, material science, chemistry, physics, and what have you. It has applications in mining machineries, plant setups, industrial machines, marine, oil and gas, electrical setups, and the energy landscape as a whole. Our resource person for today's presentation is Kofi Boakye Agyemang. Kofi is a product of KNUST and Legon, a holder of BSc and master's degree from those two institutions respectively. He has 15 years plus industry experience working in the oil and energy sectors. His experience spans technical, operational, and strategic domains. He is currently serving as the technical lead at Vivo Energy Ghana. He is a Shell licensee and play a critical role in providing high-level technical support, product stewardship, and innovation-driven solutions to customers. He had also worked with Total Energy prior to joining Vivo Energy Ghana. Kofi's core competencies include lubrication engineering, tribology, assets reliability, and sustainable energy practice. He is the recipient of the 2024 Vivo Energy African Technical League Champions Award. Kofi is passionate about monitoring young engineers and promoting STEM education. So we can all see that we have an able and competent person to take us through the presentation in the person of Kofi Boakye Agyemang. So Kofi, you are welcome and take over the floor.
Thank you. Good evening. I think I've been well introduced, so I'll skip that part and we'll go straight to the.
Kofi, can you please speak up a bit?
Okay. Is it better?
Yeah, it's better now.
Okay, so I'll go straight to the subject, and we'll take it on from there. Talking about tribology. Tribology is quite a wide subject, and to do a presentation on it in 45 minutes, I feel it's an ambush. But I'll do my best to speak to the key issues. I'll skip my introduction, and we'll go through the order of presentation. So we'll start by defining tribology. I'll touch on the core concepts of tribology. Tribology starts on three legs: friction, wear, and lubrication. So I'll touch on these three as well. We'll look at the selection criteria for choosing any form of lubricant for any kind of application. We'll touch on the impact of poor lubrication, causes of equipment failures, those ones are the ones that are related to.
Okay, please, we can't see your screen.
You can't see my screen. Hold on.
And Kofi, please, if you can get closer to the mic, we cannot hear you clearly too. It's
Okay.
echoing. Okay, we would appreciate that. Thank you.
Is it better?
Yes. Yes.
The screen and my voice. Am I audible?
Yes. For now, we can hear you. We can see the screen as well. So you can carry on.
Okay.
Yeah.
So the other presentation, we'll talk about tribology briefly. The core concepts of tribology. Tribology stands for 3 legs: wear, friction, and lubrication. I'll touch on that as well. Then I will also touch on the key selection criteria for choosing a lubricant, the impact of poor lubrication. We'll talk about causes of equipment failures. We'll touch on condition monitoring tools. Then we'll look at lubrication as a reliability strategy. We'll talk about tribology in the Ghanaian context. Then we'll come to questions. We'll come to questions and answers. Please, it's my slide. Are you able to see my slides?
Yes.
Yes, we can see.
Okay, so tribology is the science of studying interacting surfaces, and as simple as it sounds, it focuses on wear, it touches on friction and lubrication. As we all know, are the kinds of machines that we use in our plants and in our factories. They all run on heavy duty equipment, and these equipment may span from compressors, gears, transmissions, turbines. I can go on and on and on. And all these equipment, some way, somehow, they work with the principle of motion. And wherever there is motion, you cannot discount the effect of wear. You cannot discount the effect of friction, and you cannot discount also the effect of lubrication. So tribology cuts across all industries: mining, power, manufacturing, Agric, OEMs. I mean, it cuts across, all industries where machines are used. Like I said earlier on, tribology stands on 3 legs. So there's the friction part, there's the lubrication part, and there's the wear part. I'll start by talking about friction. So friction, as we all know, it's a force that impedes motion. And that force itself is not bad as people make it sound. Friction must be optimized in machine operations for us to get the desired results as far as motion is concerned. When we talk about friction, people think friction is undesirable, but it depends on how.
Yeah, Kofi.
Yeah.
Can you please be closer to your machine? We can barely hear you at times.
Okay, so I'll go back. I'll say that tribology stands on 3 legs. There's friction, there's wear, and there's lubrication. And I'll start by touching on friction. Friction is that force that retards motion. And friction comes in different forms. It can be sliding, it can be rolling, depending on the orientation of the machine in question. Friction itself is not a bad phenomenon. It depends on how it is being optimized. There are so many applications that will or may not happen if you don't employ friction. An example is how a brake system works. Your brake system is going to fail if there's no friction. I don't think as humans we can walk if there's no friction. So when we are talking about friction, we are talking about optimizing that minimum contact for machines to work. Imagine a gear working without friction. It's just impossible. So anytime we talk about friction in with regards to optimizing friction. We talk about friction with respect to optimizing friction. Friction itself is not bad, it is good, but it needs to be managed. Like I said earlier on, friction comes in different forms. It can be sliding, it can be rolling, it can be static, but it needs to be optimized to see for it to work and make a machine work efficiently. So friction itself is not bad, but it has to be optimized. It has to be optimized in all kinds of application. Now, friction comes as a result of surfaces being rough. So it doesn't matter how polished a surface looks like, it still has something we call asperities. The asperities are the peaks and troughs that we see on surfaces at the microscopic level. These peaks and troughs interlock when you have two surfaces coming into contact. And because surfaces are rough and they have peaks and troughs on them, anytime there's some kind of force sliding or rolling, these asperities begin to lock. And when they begin to lock, they give that inherent motion retardation effect. So you are expecting one surface to slide over the other smoothly, but because microscopically you have these asperities on these surfaces, they don't move smoothly. You have that effect of a force retarding it. That effect is as a result of the surfaces not being how do I put it, not being clean. When I say clean, I mean it's rough. The surface being clean in terms of its fineness is an ideal state, which you can never get. So friction is inherent in two surfaces mating and one sliding or moving against each other, because naturally you don't expect these surfaces to be as plain or as polished as possible. So definitely there's a certain element of friction in there, and friction naturally will lead to this undesirable phenomenon, where is one, sound is one, heat is another. But because we are talking about tribology, I'll focus on wear and lubrication. So wear, like you see, is a manifestation of the frictional effect on mating surfaces. And like we all see in our mechanical parts, you can see signs or manifestations of scoring. We can see signs of manifestations of corrosive wear. You can see scourging. So these are some of the manifestations of the physical effect of friction. So friction will give you wear. It will degenerate into heat. In some situations, there is excessive noise that can be dealt with. So friction, if not properly managed, will lead to wear. It will lead to excessive heat, and these byproducts can be easily mitigated. And in mitigating these byproducts can be easily mitigated. And in mitigating them, you will need to introduce a material that can separate these two mating surfaces, so that these two, the rough nature of the surfaces or the asperities, the peaks and troughs, do not come together. They don't rub off. And that material, any material that is able to do that, we describe the material as a lubricant. And the lubricant can be in any form. It can be in any state of matter. It can be a solid, it can be a liquid, it can be a semi-solid, and even in some instances, it can be a gas. So any material that is able to separate two mating surfaces to reduce the effect of friction and by extension, the byproducts of friction, i.e., heat, wear, noise. We call this material a lubricant. And the process of separating the two mating surfaces, reducing heat, reducing wear, and reducing noise to the barest minimum, we call it lubrication. Like I said earlier on, a lubricant can only reduce friction to the barest minimum. If you eliminate friction entirely, then clearly motion will not happen. Clearly, motion will not happen. Motion needs a certain amount of friction for whatever application to happen. In the case of hydraulics, you need a certain minimum frictional contact. In the case of gears, you need a certain minimum contact. In the case of engines, you need a certain amount of minimum contact between the cylinder and the piston for the motion to happen. So friction, like I said earlier on, will give you all these byproducts, heat, wear, and noise. But we have lubrication as a mitigating factor to reduce it to the barest minimum. Now, when we talk about lubrication comes in different forms. There are three main regimes in lubrication. We have the boundary lubrication, we have the mixed lubrication, and we have the hydrodynamic lubrication. So the hydrodynamic lubrication is at that stage where there's full fluid film
Kofi,
separation.
sorry, your screen is not rolling. I don't know whether you are rolling it at your end.
I'm rolling it at my end.
We are still seeing the first page. I don't know if it's the same to everybody.
Hold on.
Yeah, it's the same here.
And then if you can even go to presentation mode, that will also help more. But if
Presentation
not,
mode.
please let the screen roll.
This is slide 4. Okay.
Please guide me. I'm on lubrication regimes. I don't know if you can see it.
Yeah, it's on now.
Just popped up.
Okay. Okay, lubrication regimes. So when it comes to lubrication, there are three main lubrication regimes. We have the hydrodynamic lubrication, that is the expected state, the ideal state. And in this state, you have the two mating surfaces fully separated by a fluid film. That is the ideal and the desirable state. Then we have the boundary lubrication. The boundary lubrication is the tricky part, where if you see the general bearing, the shaft is about turning, and that's at the start of the machine. The load of the shaft, the weight of the shaft is lying on the bearing. At this point, there is contact between the shaft and the bearing, and that is at the start of the machine. At this point, we call it boundary lubrication. So at this point, there is contact, and there is no film, there is no lubrication film separating the shaft from the bearing. This is a very critical point, or the first stage in any lubrication process. This is what we call the boundary lubrication. At this point, you need a wedge or a fluid film to separate the load from the bearing. And because this is at the start of the running of the machine, we have special additives we call the EP, extreme pressure additives. These extreme pressure additives in the lubricant form coatings around the load. And when it forms that coating around the load, if there is wear, the wear happens on the surface of the coating. And this is a special additive we add to the lubricant to play that role at the boundary lubrication level. So and this is applicable to gears, it is applicable to bearings. So if you have a lubricant and it is deployed for a transmission application, then EP is critical as an additive to deal with the boundary stage of lubrication. And the boundary lubrication always starts the lubrication process. So you have the boundary lubrication starting the lubrication process, and at that point you have the bearing having solid contact with the shaft in this general bearing, bearing application. And if you don't have an EP or an extreme pressure additive in your lubricant, your machine is likely suffer excessive wear. The mixed lubrication point is where the equipment is now moving into the hydrodynamic stage. So you have a bit of the boundary lubrication, then a bit of the hydrodynamic lubrication. So at that point, in terms of exposure to wear, it's a bit mild. But the hydrodynamic phase is when there's a full rotation of the shaft and you have enough oil coming to fully separate the shaft from the bearing. And when you reach that level, that is where we say that you have reached the desirable or the hydrodynamic lubrication phase. Every equipment that relies on lubrication goes through these phases: the boundary lubrication, the mixed, and the hydrodynamic lubrication. When you reach the hydrodynamic lubrication, you don't really have much to worry about because you have a fluid film separating the two surfaces. The boundary lubrication is mitigated by the EP additive, which we call the extreme pressure additive. And the extreme pressure additive takes care of issues of wear, manages issues of friction at the start of the equipment. So these are the three key lubrication regimes: the boundary, the mixed, and the hydrodynamic. Now, we need to make a decision on what type of lubricant to use. What do we look out for? What is the selection criteria? Of course, equipment will come with manuals. They will come with OEM specification. So sometimes it is easy to just go in there, look into the manual, pick the applicable lubricant, and just move on. But the manual is guided by these parameters. First, we look at the speed. And when we talk about the speed, we'll talk about the speed in RPM. High-speed applications naturally require lower viscosity lubricants. High-speed applications naturally require lower viscosity lubricants, because if we are looking at high speed, we don't want the lubricant to also serve as a drag effect, pulling the motion back. So when there is high speed, your requirement in terms of viscosity should be low. Then when you have high loads, because you have high loads and the load is subjecting its weight on the bearing, you would want a lubricant with a high viscosity to be able to carry the load. So we have very high viscosities like the 460s and the 660 viscosity grades for very high load applications. Then when your application is temperature dependent, where you have an equipment that is operating in very extreme temperatures, like you have an environment where it is very, very, very cold. Let's say the equipment is running somewhere in Russia. You need lubricants that are blended or formulated. That are blended and formulated to deal with the temperatures. Don't forget, the viscosity is temperature dependent. So the oil will be working fine, but when there's change in viscosity, when there's change in temperature, the temperature affects the viscosity. Colder temperatures will let the oil begin to thicken, and excessive high temperatures will let the oils thin out. So you look at the ambient temperature, you look at the operational temperature as well. Then you use that to take a decision whether to go for synthetics or mineral. But as discussed, we have largely we have two types of base oils. We have the mineral oils, where we get the mineral oils from crude. Then we get the synthetics are man-made. The synthetics are man-made because we intentionally formulate the oil so that it can withstand excessive or arduous operational conditions. So if the operational condition is a bit extreme in terms of pressure, in terms of load, in terms of temperature, then you go for the synthetics, because the synthetics are artificially formulated to be able to deal with very harsh and tough conditions. Then we also have environments where water abounds, like a place where you have a slurry pump. A situation like that it's often seen in the mine, in the process plant. You would want a lubricant that can manage water washout. So there you'd go with calcium complex or calcium sulfonate greases, or lubricants with water resistant additives. Then some environments like heavy duty equipment, the equipment is subjected to a lot of shocks, and it's also subject to a lot of vibration. There you need lubricants that are additivized with solid additives. Example of solid additives: we have moly, we have graphite, we even have Teflon. These ones are added to the lubricant so that it can soak the pressure and also manage
Please, your screen. You are still on slide 9.
The vibration. I'm still on the key lubricant selection criteria.
That's right, 10. If you can push it down one part from your end.
Okay, push it down one. Key lubricant selection criteria. Please, are you there?
Sure.
No, we are not there yet.
Hold on.
We're still on lubrication regimes.
You are still on lubrication regimes.
Yes, on your screen.
Okay.
The diagrams.
Let me stop sharing.
They should change it on the screen that you are projecting, please.
Okay.
I just want to stop sharing and then share.
Hold on, let me stop sharing and share again. Yeah. Just a minute.
If they can see the screen.
Please, can you see my screen?
Yeah.
Yes.
Key lubricant selection criteria.
Correct.
So I've touched on speed.
Yes.
I've touched on load. I've touched on temperature range. I touched on water contamination, shock or vibration. Then also you look at the specification of the equipment. So in specification, the specification can come in so many forms. Different OEMs have different specifications. We have specifications also advised by the lubricant supplier. So a typical example is let me use a vehicle. Let's say you drive a vehicle and you have a requirement for, let's say, a 0W20 specification. So here you have a 0W20 specification for your vehicle. One needs to understand what the 0W20 means. And this 0W20 is a viscosity grading. When it comes to specification, you can have the viscosity grading as a specification, and you can also have the performance specification. So your vehicle has 0W20 in the manual. You have 0W20 on the vehicle as a specification. That is only viscosity. And what the 0W20 means is that the viscosity or the thickness of the oil will remain 20 grade between the temperatures minus 35 degrees and 100 degrees. So let me digress a little. So for vehicles, you normally would see viscosities 20, you have 30, you have 40, you'd have 50. That is the viscosity. Then for multi-grades, you would have and so it's always described as XW, the viscosity. So either you have a 5W40, a 10W40, a 15W40. So in the case of a 15W40, the number on the extreme right is the viscosity of the lubricant. Then the W gives you an idea how the viscosity will behave in different temperatures. And when we say different temperatures, we are talking about colder environments. Don't forget, viscosity is affected by temperature. So if your vehicle requires a 40 centistone, what it means is that it is that weight or that viscosity that can carry the load. That can carry the load of the piston. So it is 40.
But don't forget, as the vehicle begins to run, temperature will alter this 40 into maybe 30, into maybe 20, or into maybe 10. This is just a natural phenomenon. That is what is likely to happen. When temperature begins to change, viscosity will naturally also change. But the oils are blended in such a way that we've additivized it such that it can withstand varying degrees of temperature change. So if your vehicle is a 15W40, the number before the W tells you how the viscosity will behave in varying cold temperatures. So we have 0W, we have 5W, we have 10W, we have 15W, we have 10W. What 0W means is minus 35 degrees. So 0W itself is not a viscosity, it's a temperature function. So 0W corresponds to minus 35 degrees. 5W corresponds to minus 30 degrees. So if your vehicle is a 0W40, this is for illustration. If your vehicle is a 0W40, what it means is that the viscosity of the oil, which is 40, will remain 40 between minus 35 degrees and 100, because 0 corresponds to minus 35. So if your vehicle recommendation is 0W40, it means the viscosity, which is 40, will remain constant, will remain 40 between minus 35 degrees and 100 degrees. So if you take your vehicle to Russia and the temperature there is minus 20 degrees, that thickness of 40 will still be 40. It's not going to change. And this is because the oil has been properly additivized. We have polymers that we put in the lubricant for it to adjust its behavior when temperature begins to change. The same 0W40, if it becomes 5W40, 5 stands for minus 30 degrees. So what it means is that now this oil, which is 5W40, will remain 40 between minus 30 degrees and 100. So if your vehicle lubrication requirement is a 5W40, which is 40 between minus 30 degrees and 100, when you take your vehicle to Russia and you have that oil in the vehicle and you take the vehicle to Russia and temperature there is minus 35 degrees, the oil will begin to kick, because the oil is not additivized to go beyond minus 30 degrees. It is a 0W40 that can function outside minus 30 degrees. A 0W is a minus 35 and 100. So the 40 can work within minus 35 and 100. So specification is very important. Specification is very important. Performance specification is important. Viscosity specification, it's also important. When it comes to the case of gears, for gears, we have EP. The EP specification, it talks about the oil's ability to manage extreme pressure. And this is applicable in boundary lubrication regimes. So for gears, if you are starting the gear, it will go through that phase of boundary lubrication, get to mixed lubrication, then get to hydrodynamic. But if you are not able to overcome the issues of boundary lubrication, you will expose the part to serious wear before you even get to the mixed and the hydrodynamic. So the oil must be additivized enough to handle the boundary lubrication. And the oil's ability to manage wear, we call it, that performance level, we call it EP. So we have EP3, we have EP4, we have EP5. If the oil is an EP5 oil, it means it has that strength, it has that energy, it has that coating to manage boundary lubrication better than an EP4, and an EP4 work better than an EP3. So I'll give you an example of the viscosity with the automotives, and I'm giving you an example of performance specification with the EP. So you cannot take specification for granted when you are selecting lubricant for your equipment. Sometimes we decide to buy based on price. But if you buy on price without understanding the value or the performance rating of the lubricant, then you expose the machine to a lot of wear, and that will also hit your bottom line. Then there are environmental and safety considerations. You have an equipment that is sitting in a water body. We don't want an oil that contains a lot of heavy metals. So environmental specification is also important. Environmental and safety specification is also critical. For food grades, a food or a beverage plant where there is that possibility of the oil or the grease getting in contact with the food, there you go with the food grade. We have lubricants that work fine, but you can even eat them. They are not poisonous, they are not toxic. They have been specially formulated so that when they come into contact with the food or the processing material, it doesn't become poisonous or hazardous to the end user. So these are some of the key factors you need to look at when selecting a lubricant for a particular application. The impact of poor lubrication. I can't overemphasize this point. Equipment life reduction. If you don't lubricate well, you reduce the life of the equipment. And reducing the life of your equipment means increasing your operating cost. Downtime is also an issue that is tied to incessant, unplanned maintenance schedules. Production downtime, you lose revenue. Then if you are not lubricating well, imagine I told you that friction generates heat. So if you are not lubricating well, you are
in the factory, just like you mentioned,
temperature
level for you. You have
thermography will hit the roof, and it will create all kinds of hazardous conditions for the operators and the workers around that area. Research has shown that lubrication-related failures usually come from these factors. The wrong lubricant. And when I talk about the wrong lubricant, what do I mean by wrong lubricant? Wrong specification. Wrong specification. And the wrong specification can be as a result of wrong viscosity, wrong performance specification. And a typical example is you go on a process plant, because of inventory issues, space issues, cross-contamination issues, we decide to rationalize. So we are rationalizing, let's say, an EP2 grease for all or for most grease applications on site. So there you can have some wrong lubricant for some critical applications. There are some applications that require a certain consistency as far as greasing is concerned. And when it comes to greasing, greases come in different consistency levels. So when I'm talking about consistency, I'm talking about the thickness of the grease. So we have the 000 up to the 6. So 000, we have 00, we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6. The most common one we know is the 2 and the 3. That is the 2 is the multi-purpose grease that we are used to, that level of thickness. As we go up 3, 4, 5 and up, the grease becomes harder. It becomes more consistent. It becomes thicker. When we go below 2, the grease becomes soft. When we hit 0, 0, 0, 0, 0, 0, 0, the grease becomes fluid. So if for some reason you decide to rationalize because of convenience, because of cost, because of price, because of inventory constraints, then you can run into that space of using a wrong lubricant. Of course, anytime we find ourselves in that space where we need to rationalize, we also need to do a cost-benefit analysis. If we do the cost-benefit analysis and it makes sense for us to do a rationalization, why not? But as much as possible, let's try to always go with the right lubricant. Then contamination. Housekeeping is critical here. Change of filters, change of seals, all these protocols must be adhered to, because when it comes to contamination, we have external contamination, and we have contaminants that also come from within the system. So as much as possible, we must try to manage our lubricants well, right from the storage and handling process. If it's also important, our finances will allow, we can also put in a predictive maintenance tool like oil analysis to make sure that our oils are free from contaminants. Then inadequate lubrication. Inadequate lubrication. Filtration is one of them. If filters are not properly managed, they are not changed at the right time, or even when you use the wrong viscosity. Sometimes the wrong viscosity, a higher viscosity, will not allow the oil or the grease flow. So an equipment that requires maybe an EP2, because of rationalization, we decide to go for an EP3. And because EP3 is heavier or is thicker, it's more viscous, there will be grease or lubrication starvation. And when we talk about inadequate lubrication, sometimes it's not an issue of stock out. Sometimes it's an issue of going with the wrong choice, going with the wrong specification, going with the wrong viscosity. Then component wear. If issues of wear is not properly managed, it can always lead, or it can always trigger or spur on other machine failures. Under and over greasing. For under greasing, we all know the effects of under greasing. Over greasing is a phenomenon that we've not averted our minds to. When you over grease, the system builds in a lot of thermal stress. When you over grease, the system builds in a lot of thermal stress. And you see, the grease is made up of a thickener. That black or brown or that spongy feel is not what does the lubrication. That is what you call the thickener. The thickener holds the oil in place. What actually does the lubrication is the oil in the thickener. Because we apply greases in areas where we want the lubricant to stay, we deploy the use of a thickener. So you make sure that the thickener pushes, when it's under pressure, it releases the oil, and when there's no pressure, the oil comes back to stay. When you over grease, now you build in a lot of heat in the greasing system, and this heat goes to deteriorate the additives in the oil. It is the oil that is actually doing the lubrication, not the thickener. The thickener, that spongy brown or grease or black thing that you can feel, that doesn't do the lubrication. What it does is that it holds the oil in place. But if there's too much heat in the system as a result of over lubrication, then the oil gets oxidized. You know the effect of heat on oxidation. When heat begins to go up, then the oil oxidizes in no time. Then there will always be the need to change the grease, and this is also cost. Then we have other factors like extreme temperatures, operational errors like issues of misalignment, maintenance deficiencies. We have to integrate predictive maintenance or oil analysis in our preventive maintenance schedules. And sometimes, because of cost, we decide not to do any of that. We would prefer to maybe go with the reactive, depending on sometimes the financial muscle of the plant or the assets or the resources allocated to the asset manager. So these are some of the factors that lead to equipment failure, and these I'm talking about the ones that are related to lubrication. For us to minimize or to eliminate TENTA, of course, it's not possible to eliminate it entirely, but to reduce it, we need to adopt some of these predictive analysis techniques. Oil analysis is one. It gives you that predictive eye. You are able to predict what can happen in terms of failure. It also gives you an opportunity to see the condition of your equipment and also the oil. Debris analysis, we do that. We use infrared to do thermography. Temperature is a function of friction. So if thermography analysis can give you a fair idea of what is happening. Vibration, ultrasound testing, visual inspection. With visual inspection, you can use probes to go into the equipment to check how it is faring. So predictive analysis techniques is also critical. I have always advocated for the hybrid maintenance style, where you do the preventive and you do the predictive also. Sometimes the downside of preventive is sometimes you overuse resources because you have to change the engine oil at 250 hours. You are forced to change it. But good oil analysis or condition monitoring can push the oil maybe from 250 50 hours to maybe 300, and that extra 50 hours will save you money. That extra 50 hours, if converted to downtime, can increase your revenue, and that will also affect your bottom line. So when you integrate the predictive into the preventive, it helps. If you are doing the preventive alone, sometimes you realize that resources are not wisely used. Lubrication as a reliability strategy. We can deploy lubrication as a reliability strategy when we follow best practices. And when we talk about best practices, I will touch on right lubricant. And I've spoken about specification. I've spoken specification with regards to viscosity, with regards to performance. The right amount of grease. The right amount of grease. The right amount of lubricant is important, especially in cases where we are doing manual greasing. Sometimes a technician gets to the area of application. If it's a plumber block, he gets there, he gives like 7 or 8 shots. A very masculine person 7 shots is not the same as a very skinny person 7 shots. So the right amount is also important. If you go below the expected amount, you expose the equipment to wear. That is in the case of manual lubrication. If you go above the expected, like I said earlier on, you would expose the equipment to a lot of thermal stress, and this stress will end up deteriorating the additive pack in the lubricant. So the right amount is important. Now we have devices like the Shell Tactic EMV, a single point self-lubricating device that is programmed to deliver a set amount over a set period of time. So in terms of lubrication, if you plot the graph, you see that time versus amount, you have a very good and a very good perfect shape. So the right amount is critical. Then the right frequency. The timing, the greasing. Are you doing it every week? Are we doing it every day? The frequency must be based on OEM standards. The frequency must be based on best practice. Then good storage and handling. I've been to so many plants where you go and do an audit, and sometimes when you show the pictures to management, they are surprised how come the oils are being kept in those conditions. And it is real. The oils are exposed to, they are the mercy of the weather. Technicians go there with dirty rags. I've seen a situation where we did some oil analysis and there was lithium in the oil. I think it was a
Yeah, hello. Hello, Kofi. I think we've lost Kofi. I don't know whether you are hearing him.
We can't hear him. Cannot hear Kofi.
Okay, so I'm trying him on the background.
Okay.
Yeah, we can't hear you. The slides are off. Yeah, we can't hear you and the slides are off. So, and time too. So if you could speed up small. Okay, thank you. Okay, so I've spoken to him on the background. He's going to correct his screen and come back. I think he has about 3 or 2 slides more to go. Then we get to Q&A.
Yes, Mr. Mahadi. So people will be, maybe they are at work and they would want to go home. So if you can tell Kofi to speed up a little,
Yeah,
so that people who are, Yes.
I
Kofi,
did.
I hope you can hear me. Mahadi, you said you spoke with him.
Yeah, I spoke to him on phone.
Oh, okay. I hope this loss is not from the institution because it seems a lot of people are not hooked up. They are off.
He didn't actually mention what was the issue, but I'm please calling him again.
Okay, let me leave you to do that. Thank you.
Okay.
30 of us are still
on the system.
Yeah, hello.
Yeah,
Hello,
we
team.
can hear you.
Okay, so I think I had issues with my network, so I'm back. So
Yeah, so
um
Kofi, like I indicated to you, we are somehow behind time. So let's speed
okay,
up. Yeah,
so I'm almost done. I think I have about
yeah, sure.
3 more
Thank you.
slides to go. So using lubrication as a reliability strategy, you need to look at these best practices. I touched on contamination control, poor application mechanism. So the poor application mechanism, like I said earlier on, the manual greasing. Somebody's giving 4 shots, somebody's giving the same 4 shots, but in terms of the muscle impact, they are different. Condition monitoring is critical. You cannot be doing preventive maintenance without integrating. You can't be doing preventive maintenance without putting in a bit of condition monitoring. It's also critical. Then there must be a continuous improvement program where the business or the asset team are deliberate in trying to improve their systems, their lubrication system, their storage, their handling, their specifications, documentation, audit. Very, very important. Then training, very, very important. I've done a lot of trainings. I think on the average every year I do about 45 trainings in a year. There are a lot of the training, the knowledge gap is huge. The knowledge gap is huge. We need to bring in experts to touch on storage and handling specification, even for open gear or mill lubrication optimization. There are models that you can always bring in experts to push the knowledge level um, to the expected. Then documentation. We need to document our lubrication maps, our lubrication charts, so that it becomes easy for us to do troubleshooting when there is a problem. Tribology in the Ghanaian context. There are some challenges that we need to look at and address. Counterfeiting is one of them. I've seen a situation where a customer thought he was buying a particular brand. Apparently, he was buying a counterfeit of it. So if you have you have frequent machine failures, you may not know that it's as a result of the poor digitization because what you think you are buying X, but you are doing counterfeiting. The regulation, unfortunately, our regulatory body only focuses on fuel, but lubrication is one area that we need to look at in terms of monitoring. What are the popular brands? What are they selling? If it's brake fluids, do they meet specification? Brake fluids border on safety.
brake fluids border on safety? Are we sampling? Are we testing? Are we using the right glycol? Are we using the right additives for our braking systems? Regulators must up their game in this regard. Then foreign specification versus cost. Because we are not manufacturing vehicles, because we are not manufacturing equipment, most of the specifications we see in here are European tailored. So somebody develops an equipment, develops an engine, then on it he puts in a specification that speaks to European temperature environment. And because they do winter, they do summer, they do autumn, they go for the very extreme synthetics. And the extreme synthetics mean the oil must survive in a very cold climate and survive in very average or manageable temperatures. By so doing, because you are pushing the oil to those two extremes, the additivization is top notch, and that costs a lot of money. And because we don't manufacture, if we are manufacturing machines and we are doing our own oil specifications, then we'll limit our oils to our environment. We'll limit them to the mineral oils. But because we don't do that, we are tied to buying the synthetics, and that is at a high cost. I've touched on the knowledge gap. In the environment, it's a bit dusty, especially in the mining areas. So in terms of contamination control, it is important that we pay a lot of attention to contamination control. Before I sign out, I'd like to touch on these things. For engineers and managers, let's treat lubrication as a strategy to reduce maintenance costs, as a strategy to reduce downtime, as a strategy to protect the environment. And for institutions and policymakers, let's invest in tribology education and standards. Let's invest in tribology education and standards. And for my juniors, let's try and build expertise in this hidden discipline. Unfortunately, the universities may touch on lubrication, but as a technical trainer, having done this for about 15 years, the knowledge gap is huge. The university can still look at their curriculum to integrate lubrication. It is important. It's an asset. Lubrication knowledge is an asset for every reliability engineer. It's an asset for maintenance practitioners. I'll thank you for your time. This is where I'll take questions. Thank you.
Yeah, so thank you very much, Kofi. So at this point, we open the floor for questions. We are allowing about 15 minutes for questions. The floor is open. So let's see if you are having any clarification, question, anything, you can raise your hand using the effigies at the bottom, then I will call your name for you to ask your question. At this point also, Chair, if you would want to say something. Because of the time, yeah.
Hello. Yeah, just listen. My name is Maxwell.
Okay.
Yes. It has been very educative, but I want to know, would there be any other one? Are we going to continue, or this is just the end of this session?
Okay, so like I said in the intro, this is a very broad topic, and you can see from the presentation that he did, even though it can be summarized as a high-level presentation, he also tried as much as possible to come to the workshop floor at some point. We have some takeaways to take home. So depending on the interest that we as members show, we may tackle certain issues separately so that we can have Kofi or people like him come and giving more details on specific areas of this topic. Thank you.
Thank you very much.
So I can see Alfred. Engineer Alfred, your hand is up. You can please talk or ask your question.
Thank you so much, Kofi, for that educative presentation. Now my question is, you grouped the oils into two. You said we have mineral oils and synthetic oils. Now I wanted to ask, are those like the two main types of, should I say, oils that are used, or what was the how would you group them? Is it like the two main types of oils, or what is it? That's what that's my question.
Okay, so so what comes together to form the oil? We have the base oil and the additives. So for the base oil, we have three main categories. We have the synthetic, we have the mineral oil, and we have the vegetable oil. But the vegetable oil is obsolete, so we don't normally talk about them. We have the mineral. The mineral, we get it from crude. So the base for the mineral is from crude, petrochemical, where we do fractional distillation. We take all the distillates out. Then what we get as the base, we additivize the base based on the application. What you use to additivize the base oil for gears will not be the same as for an engine, because a gear will require a lot of EP because of the meshing of the gear tooth. There's a lot of extreme pressure, so you need a lot of EP additives for that. If you are blending for engine oil, because of combustion, the heat that comes with combustion, the oil must be able to withstand temperatures. The oil must be able to clean, because combustion also comes with a lot of undesirable byproducts because of the nature of the fuel. Combustion will always generate sulfurs, which will go to some extent score the faces of the cylinders. So you will need a TB and a cleansing agent to clean all the undesirable effects in the engine. So we have two main types of base oil. We have the synthetic, which is man-made. The synthetic is man-made. So let's say we have a cold room. We need an oil for the refrigeration compressor, because the cold room is operating between 0 degrees and maybe -3 degrees. If you go with the normal mineral oil, the mineral oil will naturally it will thicken, because temperature affects viscosity. So this time around, we'll say that, okay, we want an oil that will defy the basic physics laws. We want an oil that when temperature is going down, the oil will not thicken. So we go to the lab, we put in additives that will counter the effect of the varying temperature changes. And every oil that we create in the lab, which is man-made, to manage adverse operational and environmental conditions, we call those oils synthetics. So those are the two main categories. But the vegetable one, which is obsolete, that's the base oil. Yeah.
Okay. All right. Thank you very much, Kofi.
It's my pleasure.
Okay, so thank you, Engineer Alfred, for your question. I can see Engineer Joshua Ashiti. You can please take the floor.
Thank you very much for the opportunity given. Please, I need clarification or more explanation on the EP. Actually, the network wasn't favorable at all, so
okay.
I wasn't able to. Yes, thank you.
Okay. So the EP we have different types of additives that we put in the base oil for the oil to work fine. Historically, we've been relying on the viscosity, on the thickness of the oil to make lubrication efficient. So 30, 40 years ago, we were lubricating with very thick oils. And even today, our mechanics believe that if the oil is thick, it's good. But we've moved far away from that. Now technology has come and we have additives. Even very light oils can manage friction better than thick oils. Why are we able to do that? We are able to do that because of additive technology. So we have a special type of additive we call the EP. The EP is extreme pressure. Extreme pressure. So where, like the boundary lubrication phase, where we are coming to start the material, we are coming to start the equipment. The shaft is lying on the bearing. The shaft is lying on the bearing. It's lying on the bearing. You start the mass. You start the equipment. The oil is beginning to come in. It's beginning to fill the clearance space. At that point, the machine is very vulnerable. It's very vulnerable because we anticipate that every machine will run through the boundary, the mix, and the hydrodynamic lubrication phase. We put in an EP, an extreme pressure additive. What this additive does is that when temperature begins to increase, okay, microscopically, there's a coating that will coat the shaft and also coat the bearing. So even if there's attrition, the attrition is between the coating. The two metals never touch. That's what the EP additive does. So anytime temperature begins to build up, the EP additives now form a coat. Where will the temperature come from? The temperature will come as a result of friction. When the two surfaces begin to meet,
friction will naturally generate into heat. And when the additive begins to feel that heat, it changes, it metamorphoses into that layer microscopically to cover the shaft and also cover the bearing, so that the attrition is between the surfaces, is between the coatings, not the metal. And we call that additive EP. So for gear oils, we always look at the EP level of the gear oil. And the EP level is also a function on the type of gears. If you have a worm gear, the attrition level is different from a spare gear. If you have a hypoid gear or a bevel gear, the attrition is different from a spare gear. So a spare gear can say, okay, put in a gear oil that has an EP4. So the EP4 is a performance rating. But if you are going for, let's say, a worm gear, which is technically a reducer, the attrition is very high. So it will require an EP5. So the EP5 is a type of additive that we put in gear oils, but it also become a performance specification. I hope I've answered your question.
Thank you very much. Very clear now.
All right.
Thank you very much, Engineer. So we have Engineer Eric Aqua. After Engineer Eric Aqua, we have one more person and we'll bring the Q&A to an end. So Engineer Aqua, you can please take the floor.
All right, good evening, colleagues. I'm in a noisy background, so I couldn't ask. I started. My question essentially is that do we have waste lubricants, and how do you dispose of the waste lubricants? Thank you.
Engineer, we can barely hear you. Kofi, I don't know whether you are hearing him well.
No, I think he was saying something about waste oil, but
yeah, his question is in the chat box. So if we can look at it, he's asking how we can dispose of the waste lubricants. Please check the chat box and see
whether we have waste lubricants.
Okay.
Okay, I can read. Good presentation. Please, I want to know how you dispose of waste lubricants. That's his question.
Yeah.
Okay.
I think it's a good question because we have an environmental component in there. So Kofi, can you please?
Okay, so for waste oil, we have an environmental management system that speaks to waste oils. So waste oil, racks, filters contaminated with lubricants, we treat them as hazardous fluids. We have companies that are certified to handle waste. It's always advisable to call them. You must have a segregated, a special bin for that, for waste oil. So you separate your waste oils from your normal food waste, your normal everyday waste. You separate them. Then you call those certified to come and dispose of it. Some of this waste oil ends up in recycling plants. We have some recycling plants that are able to turn the waste oil into other useful material. But on site, try and keep your waste oil, your racks and your filters, treat all of them, put them in one category, and call on the certified waste management companies to come and deal with them. It's not supposed to go into the environment. Yeah.
Okay. Engineer, are you satisfied with the answer? Okay, so we'll take the okay, thank you, sir. So we take the last person, Engineer Emery Ibrahim. Can you please take the floor?
All right, thank you so much for this opportunity. My question is, I want to understand the oil analysis when it comes to the tribology. Can you do it on site, or you will need a lab to do that for you in case you don't have a lab?
Okay, so you will need certified labs to do that. If you have money and you want to invest in
some equipment. There are some basic tests you can run on site, but you still need some certifications, some trainings for you to be able to do that. I can say that for Shell, they do it free for all their customers. So you may have some of the companies who do it free for their customers. If you buy from them, they do the oil analysis. They do the oil analysis for you for free. But you can also explore the option of bringing in some basic equipment to test particulate count, to check viscosity, to check wear metals. I mean, that can be a starting point. But if you want a comprehensive one, then you'd have to secure the expertise of some of these laboratories. I won't sell anybody. That won't be fair. But I can say that there are some companies also that when you buy from them, they do the oil analysis for you for free. And Shell is Vivo Energy is one. It's unlimited. It doesn't matter the number of samples you are doing. They do the analysis for you. Give you the bottles, all the accoutrements that comes with the oil analysis. You take it yourself, and you submit it to the lab. They work with WeCheck. They do the analysis. They share the report with you. So that's it. Yeah.
Okay, thank you so much. But I follow up. I just want to understand this one, thermography. What does it mean when it comes to this?
Friction, like I said, friction will always churn out heat as a byproduct. If you are lubricating properly, you should not have heat in excess. What thermography will do for you is that to give you a fair idea, the temperature levels as against the optimum. So if you are reading your thermographs well, you can tell that you are going below or above the expected, and it can tell you that no, something is going bad. So when you integrate thermography in there as a condition monitoring tool, it guides you as to how you are managing friction. Lubrication is to manage friction. If lubrication is not properly done, friction will be on the high side, and your temperature levels will also be on the high side. Yeah, thank you.
All right, thank you so much.
Yeah, thank you, Engineer Ibrahim, and thank you all. Engineer Chair, can you please come in? Do you have anything to share?
Oh, Mr. Mahdi. Okay, so maybe I should say something at the end. So if you permit me, I'll end the presentation by saying something. Do you permit me to do that?
Yeah, so you can please take the floor.
Okay then. Kofi, I want to say thank you for this wonderful presentation. I will tell you, if you look at the questions people were asking, you can see that people are interested in how we manage the oil.
Sure.
I would discuss with Mr. Mahdi, and then we will look at doing another one for the whole institution on the type of oils and their effects on our vehicles. People don't know that because of turbochargers on our vehicle, you need to go in for very light oils. And if you don't take care, because of the small bearings that they run on, people don't know that some run as high as 200 revolutions, 200,000 revolutions per minute. And in other words, if you put in the wrong oil, you would definitely damage them. And you see, I realize that in this country, because you don't get the damage immediately, people are not able to determine that, oh, it is because of the wrong application. So we will find time with my executives, and then we will arrange one for the whole institution, so that you give them, or you give all of us a presentation on loops for our vehicle. I want to say thank you very, very much. And I want to also say thank you to our host, Mahdi, for how he handled the program. His co-host, Dennis, and Naomi, you guys have done so well, and I really appreciate your effort in organizing this. Those of you were able to come on this presentation, I want to say thank you very much. At least let our other colleagues know that we learned so much on this. Look, if you come on such programs, there are things you pick up, but you don't know. And I learn so much anytime somebody presents something. And if I tell you what I've learned, you say, oh, really? People don't know what synthetic oil is. People don't know what mineral oil is. I wanted to ask him the difference between semi-synthetic and synthetic, but I know we'll do it at another time. So I thank you all. Thank you for the presentation. Thank you. Over to my host.
Okay, thank you, Engineer Dr. Che. So, like our elders say, when the elderly baths, it means the water in the house is finished. So I wouldn't want to add much, but I will leave us all with this takeaway that from the presentation, we realize that just as overspeeding kills, overgreasing also can kill your machines. So we say we should look at the right loop, the right amount, and the right frequency. So there are some 3 hours there. For those of you who are a fan of formless, you keep the 3 hours, and I think we'll be good to go. So Kofi, thank you very much. Like the chairman said, thank you for honoring our invitation. Well done, and we'll talk again and see you again. Thank you all for coming.
Thank you.
Thank you.
And bye.
Maxwell, salute.
Abiri.
Hello.
Maxwell.
Yeah, Abiri.
How are you?
By His grace, how are you too? It's nice we've met here.
Sure.
Yeah.
All right. So
I'll give a. Is it?
I said we'll talk after this.
Yes, I'll give you a call after this.
All right.
Mr. Hamadi Hassan, please. I want to know if the slide can be shared to our users.
Yeah, I will please discuss that with Chair and get back to you. So we post that on the platform when what the decision will be.
Thank you very much.
You're welcome, sir.